I am happy to introduce Arman, who I just learned is the executive director of the upcoming Typelevel Foundation, but I don't want to steal too much of your thunder, and I'll let you explain for yourself. Give him a big round of welcome.
Hi, everyone. Thanks for being here. Yeah, I guess I gave away some of it. We announced yesterday on the blog, but Typelevel is sort of growing up a bit. We're becoming a nonprofit in the US. We're calling it the Typelevel Foundation, and at least for now, I'm helping to get things off the ground. I wanted to talk quickly about this photo. You know, I saw the Scala Days promotion stuff. I'm like, that looks like where I live. Except we don't have sailboats. We have these big ferries. That's the Washington State ferry system crossing the Puget Sound and ancestral lands of the Coast Salish people, also known as the Seattle area. Yeah, so yeah, we also have that's the Olympic Mountain. So I was like, this looks very familiar. Yeah, a bit sunnier there right now though. So how many people know of Typelevel? Amazing, love to see that. So yeah, so Typelevel. A lot of people know Typelevel because they talk about like the Typelevel libraries, the Typelevel ecosystem, CATS effect, and HTTP4S, FS2, things like that. But like Typelevel is also a community, and like that is a big part of it. And you know, we were applying to Google Summer of Code, and we had to write a little pitch about who we are. And I think what Typelevel is about doing functional programming together. And it's about having really safe and inclusive environment to collaborate and work together on these projects that are like really fun and interesting, and even, you know, sort of pushing the boundaries and doing some kind of research, but also like widely adopted in industry and lots of projects. So, like, thank you everyone who is using our stuff. Like that's really exciting.
I just want to say thank you for bringing Haskell to Scala.
Yes, yeah. And I guess that was maybe some of the start, but like we've sort of gone a lot of new directions too. Yes, and so yeah, Typelevel has had some governance changes like as of this week. So yeah, we are becoming a US-based nonprofit, and so that will have a board of directors. I'm also serving on the board of directors and as an executive director, but it's going to be overseeing like Typelevel's policies and finances. Previously, there was the steering committee, which was doing a lot of that work, and now the steering committee is going to be more focused on the technical aspects of Typelevel, like really guiding the development of the libraries and things like that. If you haven't heard of it, there's a bunch of other teams that are really involved with Typelevel. There's the security team, and they're very much behind the scenes because we're receiving the reports of vulnerabilities and things like that. You know, that's how that's handled. And then also an important part of Typelevel is that Typelevel has got its own code of conduct, which we forked from the Python code of conduct. And an important part of that is it also includes an enforcement policy. So there's a code of conduct committee, and all the members of this committee do a training about how to enforce code of conduct and how to engage and things like that. And so, yeah, this is a really important part of Typelevel. We're not just about the code, but about the community and being a really welcoming and safe space. So I really don't like giving long talks, like seeing like a 40-minute talk slot or something. So my cheat code was retrospective, and like not in the idea of like looking past, but in like this is sort of a compilation of some works. So actually, I'm going to show you sort of. I'm trying to make this into 3 mini talks. I'm going to talk about like three interesting things in Typelevel. The period of time is the period of time that I've been involved, which is maybe the last 3 or 4 years. So Typelevel's got a lot more history. Les can tell you, I guess, co-founder and stuff. But yes, so, and what I'm really interested in, like from my time in Typelevel, is how do technology and community interact in this open source space? Because I've participated in Typelevel, like working on the technology, but most of all being part of the community. And it's really amazing to see like what happens sometimes. So like one of the projects I want to talk about, this is like maybe like one of the second things I did when I got involved with Typelevel was I helped create this project called Sbt-typelevel. Who's used Sbt-typelevel or knows of it? Okay, a few people. So Sbt-typelevel, it's a plugin for SBT, and it basically configures your build to do all these like really useful things. Development, testing, cross-building is a big one for the different platforms, Scala.js and Scala Native, publishing to Sonatype Maven, and then also like creating documentation, like a website for your library. And so it obviously integrates with a bunch of tools. I've shown some SBT, Sonatype stuff. Leica is a really cool documentation website. But like another really important part of Sbt-typelevel is it's got this focus on semantic versioning, which is like how version numbers relate to compatibility of your library, especially binary compatibility. And like, so to talk about like what all of this does is like, if you type sbt new typelevel / typelevel.ga, that command there, so that's a getter template. This is a pretty cool thing in the Scala ecosystem. So that'll generate you a template that does all these things for you out of the box, which is it auto-generates GitHub Actions workflows, so your CI is configured. It sets up versioning that is based on Git tags. It sets up this compatibility checking, which we're going to talk about in a little bit. It sets up CI publishing for you. It sets up a CI deployed website using Leica. And it auto-populates a bunch of other like random boilerplate settings that you don't want to worry about, like API docs and source maps and all these random but useful things. So you get all of this out of the box when you use Typelevel, especially when you use this template that we have here. So that's you run that command and you get all of this. So why do we care so much about compatibility? And so again, this like comes to Scala and a lot of the Scala ecosystem being run by the community, being community-driven development. And so when you're doing community-driven development, we can't just all be perfectly in sync with each other. So instead, we have to have these compatibility contracts to make sure that somebody can release a new version of their project without forcing everybody else to reissue their library. To give it like a really concrete like example of this, suppose like you're building an app and you want to use the Woozle library, and you also want to use the Heffalump library. And you want to use like the latest Woozle library, which is 3.2.1, but the Heffalump library, which you're using, was built against a slightly older version of Woozle, in this case, 3.1.4. So what happens at runtime is actually this process called eviction, where the old version of Woozle gets evicted, and you're using just the one version, the latest version. So even though Heffalump was built against this old version of Woozle, suddenly needs to be running at runtime against this new version of Woozle. So that's why this compatibility constraint is really important. And again, like this is a community ecosystem. Like you can't just go banging on Heffalump author's door and be like, I need you to release a new version, like, you know. So like compatibility is like so crucial. And it's really hard to get compatibility like correct. So like here's like an example. So if we've got this like Wheeze method in the Woozle library, and like something that might seem like it's binary compatible is like, oh, like we'll just add this additional parameter to a method and give it a default value. So like that should be fine, right? That's compatible. No, that's not binary compatible. And there's actually, Li Haoyi has got this SIP that helps a little bit with that. But like it's really, really easy. Like beware, it's easy to fall in these traps. And so this is why a big part of Sbt-typelevel is configuring a tool called Mima, which does this binary compatibility checking as part of CI. So your CI will fail. You'll be unable to release a new version of your library if you've made a mistake like this. Yeah. So it's like having correctly configured builds, especially with respect to compatibility, is like essential for our open source ecosystem's health. Like this is how we work together. Yeah. So at the time when I started working on Sbt-typelevel, it was because I was working on Typelevel. I was working on a bunch of Typelevel's organization projects. So these are the projects that are literally under the Typelevel GitHub, and you know, like Cat's Effect and things like that. And it was each of them had their own unique build, and it really helped to centralize things. But Typelevel not only has its organization projects, but you may have heard about something called affiliate projects. And this is a way for projects outside of the direct Typelevel org, projects from the community to participate in the Typelevel ecosystem too, like more explicitly. So an affiliate project is basically a community project that declares some kind of like alignment with our ecosystem. And one thing that's important is that all projects, whether they're an organization, a Typelevel organization project, or a Typelevel affiliate project, are open source licensed, and they also follow the Typelevel code of conduct. So anyone can submit an affiliate project. You basically open an issue on the Typelevel governance repository, and there's a template there that will help you with that. Yeah. So to put into some numbers, we currently have 38 organization projects and 48 affiliate projects, which is wonderful. And one of the things that Sbt-typelevel was designed to help with was to make it easier to cross-build, to support multiple platforms besides the JVM, Scala.js and Scala Native. And it's hard to know things for sure, but one of the things I like to believe is that because we made it so easy to just do that SBT new, create that template which sets you up for the publishing and the cross-building, we have contributed to this helping foster this wonderful community-driven ecosystem of all these libraries that are high quality because they have the compatibility checking and they have support for multiple platforms. So in fact, almost 3/4 of the libraries support at least one platform besides the JVM, and over half of them actually support 3 platforms. So that's JS and native in addition to the JVM. And one of the things I also think is interesting is there's a lot more libraries that are supporting 3 platforms instead of the 2. So it's we've sort of come to a point which is if you're able to support Scala.js or Scala Native, you're probably able to support the other one too. So I think it's wonderful to see this community ecosystem that's hopefully very much supported by this tool. Another thing I did was, it's hard to know. I don't know. That's part of why I come here. I want to know how some of these open source projects are used. But if you do a quick GitHub search for Sbt-typelevel usage, it comes up with almost 400 results. And the top one is some Spotify project, which I found out today is using Sbt-typelevel. Yeah. So, yes. So, to leave us with this is a great quote from Fabio, one of the FS2 maintainers, which is they ported some of their builds to Sbt-typelevel, and it reduced them from a week of existential dread to half a day of existential dread. So, if you identify with that, yeah, Sbt-typelevel might be something to look at. All right, this is the end of talk 1. Next, I want to talk a little bit about Scala.js, Scala Native, and Cat's Effect. Because this is also, I think, this really interesting story. And it's because, when I think about community, I think Scala.js and especially Scala Native have been, in large part, very community-driven. Because in some sense, they are kind of creating this new ecosystem. A lot of really great work came out of EPFL and Virtus Lab to get these platforms up and running. But it was a lot of the community effort to port libraries and get libraries working on these other platforms as well. And so to talk about these, so Scala.js is a Scala to JavaScript compiler. Scala Native is an optimizing ahead-of-time compiler for Scala that it's basically using LLVM to make native executable binaries. And Cat's Effect, if you're not familiar with it, it's an asynchronous runtime for Scala. And so the main things that Cat's Effect is providing is an IO monad, which is what we use for managing side effects, and also a high-performance runtime for this IO monad. And the runtime supports the JVM, browsers in Node.js via Scala.js, and native as well. And an important term to know for Cat's Effect is fibers. This is how we support concurrency. And fibers are basically, you can think of them as sort of lightweight threads. And so, yeah, so it was because of, I think, this community, it's really because of the community excitement for Scala.js and Scala Native, that was a big incentive for us to want to support them in Cat's Effect and try and figure out how to do that. And so another great quote, this is from Daniel on the Typelevel Discord. He says, "We're really at the cutting edge of some incredibly bizarre stuff." And yeah, let me talk about that. So when Cat's Effect was conceived, this is sort of what the thread pool best practices were. So Cat's Effect was originally created for the JVM, which is very much a multi-threaded environment. If anything, we were the Cat's Effect. One of Cat's Effect's sweet spots is actually on the JVM when it has many threads. That is a system that it works well in. And there's this best practice of how the thread pool set up that Cat's Effect was really occupying, which was an important part is having this having a big work stealing thread pool for a big compute pool, bunch of threads doing the compute work, as well as some threads for doing event dispatch. So this means I/O and also things like scheduling timers and stuff like that, and also some threads for doing blocking I/O. Yeah. So this was where we were starting from. This is how we conceive Cat's Effect to be working in this multi-threaded system with different threads playing different roles and things like that. So this is a challenge for supporting non-JVM platforms because JavaScript and originally Scala Native 0.4, which is at the time we were trying to first do the port, these were single-threaded runtimes. So this really, this forced us to rethink things a bit. So one of the good news is that concurrency, which is one of the things we want to support, concurrency does not require parallelism. Concurrency means you can have like many fibers executing things not exactly at the same time, but not having to wait for one whole fiber to finish before starting to the next one. They can be multiplexed. A fiber can be paused in the middle of its execution, another fiber can start doing some work. So fortunately, concurrency does not require parallelism. But the other challenge is we really want to do I/O, right? We want to be able to do networking. We want to be able to read and write files. We want to be able to talk to databases. And the way that I/O is implemented is with dedicated thread pools. This is how we do it on the JVM, and that's part of that, this best practice. We have these event dispatcher threads and blocking I/O threads, right? So we don't have that either. Fortunately, JavaScript runtimes do offer asynchronous APIs that we can use for doing this I/O. So the JavaScript case was a bit figured out. Like, for example, Node.js offers a bunch of APIs. But for Scala Native, those APIs just weren't available because Scala Native was, implementing the JDK, and it couldn't implement a bunch of JDK APIs without threads and stuff like that. So on Scala Native, we were really in this like single-threaded situation, and we didn't have APIs available. So we had to sort of like start from scratch. And so it was great that actually we did all this work figuring out how to support Node.js with Cat's Effect and the Typelevel stack, because Node.js uses a library called libuv. UV stands for Unicorn Velociraptor. Well, there you have it, yeah. And it's an example of how you can make a successful runtime with primarily a single thread. And so most of the libuv stacks are like libuv, like TCP, that's like for HTTP and databases, and like pipes and a few other things. All of this is actually designed to run on your main thread. And then there's some things that you need a thread pool for because they're blocking like file I/O and DNS and stuff like that. But a lot of the really interesting stuff, which is TCP, which is like, for example, you want to be making client calls or talking to a database, like that's HTTP. All of this can all be done. It's all designed to be done on your main thread. And so the way that libuv has accomplished this and the way Node.js has accomplished this is they basically have what's called an event loop. And it's this loop that's designed to periodically check for I/O, but also like interleaving with tasks. And so like we found a lot of inspiration in how libuv does things. And by the way, like this is actually can be a strength. So this is a bit of a tangent, but one time we have this project in Typelevel called Firo, and it's specifically for making serverless lambdas. And one of the things you can do is compile them to JavaScript instead of for the JVM. And somebody came into our Discord once and like shared these really interesting results, which is not only is the cold start better, the average duration of running your Lambda on Node.js is faster than the JVM. And that's because in the case of Lambdas where you only have like a single core machine, having less threads is good, even as fast as the JVM is with just-in-time, compilation, all this stuff. Like, at the end of the day, having a lightweight runtime, the way libuv and Node.js are designed, that's what wins. Yes. So there's advantages to thinking about these different runtimes and stuff like that. So anyway, so we took a lot of inspiration from libuv. We looked at this, and actually we realized that we can take all these ideas we learned from figuring out how to support Cat's Effect on native and how Cat's Effect works on JavaScript, and Daniel came up with this I/O integrated runtime concept. Which is this idea to take sort of the libuv event loop and build that directly into the Cat's Effect JVM runtime, the multi-threaded runtime in the JVM. And I really want to talk about this, but I can't because you're going to see Antonio talk about it tomorrow. So please go to Antonio's talk in this same room tomorrow. It is very exciting. It talks about this integrated I/O runtime that we came up with, and then Antonio went and ran with that for his Google Summer of Code project with I/O U-Ring. And like this is like a major step forward for like just multi-threaded concurrent runtimes in the JVM world and just generally. Like we're very proud of this work. So I can't talk about it. The punchline comes tomorrow. But the punchline for the purposes of my talk is that we tried so hard to figure out how to implement the CATSFX runtime for Scala.js and Scala Native, that led us to the ideas that are now advancing the JVM runtime. So it was like this community excitement about Scala.js and Scala Native that just forced us to look at problems in different ways and think about it differently. And then now, yeah, it's this big change for the JVM runtime. And we're very excited also to be releasing CATSFX on Scala Native for the Scala now multi-threaded Scala Native runtime too. So this is actually pretty similar to what's on the JVM now too, now that Scala Native has caught up and offers multi-threading. So yeah, it was just this really amazing thing of working on the problem from different angles and different platforms. And yeah, next we're looking at WebAssembly. That's what's probably going to be next. Okay. And then the last thing I want to talk about today is Scala CLI. Another great thing from Vertis Lab. Who's used Scala CLI? Yeah, that's great. You know, that existential dread from SVT takes you right to Scala CLI. So Scala CLI is a great project from Vertis Lab, which is gives you this really fun to use command line tool interface for the Scala language. So it just makes it really easy to like run your Scala codes without having to make a whole build and stuff. And so who's used toolkits with Scala CLI? Great. Who's used the Typelevel Toolkit? Wonderful. Oh, good. Yes. So this is like one of the really cool things is that Scala CLI, like, it's already coming from this idea of like, how can we make it easier and faster to use Scala? You know, just get started and do things. And like, the next step to that is like, okay, how do we power it with the libraries we need to get started? So there's the Scala toolkit that came out, and we're really happy that we were able to create the Typelevel Toolkit and also add that directly into Scala CLI. So you can do just using toolkit and ask for the Typelevel Toolkit. So yeah, so what is a toolkit? So a toolkit, in at least the Typelevel Toolkit, like what does it include? It's sort of this super library, or it's this toolkit that includes a bunch of libraries within it. So the Typelevel Toolkit includes an effect system, it includes an HTTP client, includes ways for dealing with processes and file I/O, includes both a JSON and CSV reader and writer, includes a command line parser, and of course a test framework. And yeah, so we're just talking about all this cross-platform stuff. Like one of the awesome things about the Typelevel Toolkit is that because we have these amazing community of cross-platform libraries that are published with compatibility, high-quality compatibility and multi-platform, like you can write your code once, the same code, and it will compile for the JVM and Node.js and or Native. It's using the same libraries, the same code, because everything is offering the same interface. It's a very uniform interface. So these are the libraries that are included in the toolkit. Do people recognize all the logos? Well, okay, the one in the middle, CATSFX, and then HTTP4S, and then FS2, and Decline, which is a cool command line parsing library, Kirkey for JSON parsing, FS2 data, a few modules of that. It's an amazing project that like parses so many different data types, and then Weaver is a concurrent testing framework. Yeah. FS2 data? Yeah, FS2 data. Yeah, FS2 data is a really cool project. You should look at it. Like, this is where we get the CSV support, but it also supports JSON. It supports like a bunch of other formats. It's amazing. And because it's all written in Scala, that's why we were able to. They've actually been able to port it to support all the platforms. So like, this is a multi-platform parsing serialization library and streaming, because it's based on FS2, which is the streaming library. Yeah, so it's a pretty awesome toolkit. Yeah, and it's cross-platform, and we've got like the great compatibility guarantees and stuff like that. And so like, again, like this is awesome. Like Scala CLI makes it easier to use. Get started with Scala. We've packed this like jam-packed this toolkit with all these like great libraries that let you just get started in doing things. But like, there's still more that can be done. And so this idea came up, and it ended up being a Google Summer of Code project by a student of ours named Gabby. And Than's in the room. Than was one of the mentors on this project, along with Michael Pilquist and Antonio Gela and Rishad. The idea was like, how can we make some of the Typelevel libraries just a little, reduce the learning curve a little bit, make it easier to get started, and also just make it easier to do stuff sometimes. So this project was basically creating a library called CatScript. And it offers a strict non-streaming API for interacting with the operating system for like things like files and processes. And so to like make it really concrete, I don't know if anyone was at Zainab's talk like earlier today, and like there was this, everywhere there was this compile.drain or this compile string, like that's how you do things in FS2, and like there was a question like, what is this for? And like we're not gonna talk about that right now, you just have to have that everywhere. Like, what if you didn't have to have that everywhere? So that's really what CatScript is offering, is it's offering these same APIs for interacting with the OS and doing files, but it's just making it strict. It's non-streaming. Now, of course, there's caveats to this, like streaming is really awesome when you're working with huge files and you don't want to load everything in memory, or you want to do complex things, and streaming is fantastic. But it also has some overhead, and sometimes you just want to read the whole file into memory and get on with your script. So we came up with this project, CatScript, and Gabby worked on that for their Summer of Code project. And if you want to see an example of how to submit a project to the to become a type level project, like this is how you do it. You just make an issue, you give a small project description, and that's it. And then the steering committee discusses it. Yeah. So Gabby proposed the project, it got accepted, and the awesome thing about CatScript is it's not just a great library for interacting with files and things like that, but Gabby spent a lot of time writing some amazing tutorials about how to use it to write scripts, how to use it for these different tasks. And so, yes, it's both a library that makes it easier to onboard to using the type level ecosystem with Scala CLI with a bunch of examples. So yeah, there's this really great theme of how do we make some of these tricky concepts that we've had for a long time in the type level stack. How do we make things easier? And oftentimes, like, just better. So another thing I want to call out from Than is, who was a mentor on this project, is he's giving a talk in this room at 5, it looks like, about this new way of dealing with, of sort of replacing things like either T and these monad transformers with sort of a capability-inspired approach. So yeah, I won't spoil this one either, but you should come back with Than's talk. And again, it takes this concept that's been around for us, like how can we implement this in a different way and make it easier to onboard and actually work better in this case too. Yes. So thank you everyone. These were my sort of 3 mini talks about like what's going on in type level and all these like fun ways that the community and the technology have gone together. And last of all, I just want to say, like, please talk to me. Like, I put the green sticker on my badge. Like, come talk to me. I've been on the open source side, but I don't really know much about how type level is used out there in industry. So tell me about how you're using it in your organizations or your personal projects. I want to know what your wishes and dreams are, what your pain points are. And if you want to get involved, like, please definitely talk to me. There's so many ways to be involved in the community. You can contribute. If you've been a contributor, like, please consider stepping up as a maintainer for a project you're involved with or interested in. Submit your projects to be affiliates. I mentioned there's a couple different like important committees. Consider serving on a committee. We're doing Google Summer of Code every year now. You can help mentor a project. We've had lots of great students every year. Jose's another student that's sitting in the audience. Yeah. And yeah, just hang out on a Discord server. Like, that's really how I got started. And there's a lot of really interesting discussions there. It's a great space. Yeah, if you're a student and you're interested in doing Google Summer of Code, like, let's chat project ideas. And yeah, I would love to talk to you about the Type Level Foundation and how you can support it. Like we're really looking forward to working with you, and we're looking for your support. So yeah, thanks.
Thank you, Arman. We have enough time for questions. Okay, that was fast.
Yes. Yeah. So with all this talk about Scala.js and Native, yeah, you say you don't have a much overview of the industry, but I was exactly going to ask that, how many people actually write front ends in Scala? Because even though the technology seems to be there, the front end community is somehow is like miles away from Scala. I'm not even sure they know that this exists. So is anyone using Scala.js and writing front end?
I mean, let's just by asking the audience, who's using Scala.js at their companies? Oh, here we go. So It's interesting. You talked about front ends, but one of the projects I talked about briefly was Fuel, which is a sort of a Scala.js backend project using Scala.js to make these AWS lambdas. So this backend applications to serverless applications. I don't know, like, I'm coming here to get a bit of the community pulse. Some of the pulse I have is I do see Scala.js front ends being used a lot, sort of maybe not the consumer-facing products, but a lot of the internal teams are using it for making internal tooling at their companies. Sometimes you see really cool stuff. I have a project called Calico, which is sort of a type-level front-end library, and maybe about a year ago, an Apple job posting came up, and it's like experience in Calico. Okay, so Apple Maps is using Scala.js type-level JS for something. So yeah, it's out there.
And by the way, when we introduced Scala.js builds in type-level, it was quite fascinating, if I may, because a few people were quite reluctant early on because many people believed that Scala.js would introduce a lot of complexity in the builds and was not mature yet. So a bunch of people just forked type-level libraries and provided Scala.js builds. So there was massive demand that we would provide, and eventually we provided Scala.js support many years ago, but it is like we did not do that because we were bored, because it was really complex to support initially, and now it's much better, but there was significant demand at the time. Further questions?
Hello.
Hi.
Thank you for the talk. So on the Scala Native side, I know it's been a long road to get Cat's Effect on Scala Native 0.5, issues on Scala Native side, issues on Cat's Effect side, interesting experience. Now that it's sort of there, and like a lot of the native specific stuff is in the runtime, are there any plans to use native specific code in other parts of Cat's Effect? So for example, Daniel's rewriting part traverse n, right? At the moment, for example. So are there any parts to use the more dangerous and more sort of delightfully delicious parts of Scala Native with like unsafe memory management in parts of Cat's Effect that already work because they cross-built, but could be implemented specifically for native just for performance or other reasons? Do you have any ideas on how to do that?
Oh yeah, I definitely have lots of ideas. One of the more interesting ones, I think I have an issue up with this, and I've done an experiment. It's in the Cat's Effect repository. It's like, what if we like totally redid the fiber implementation to be taking advantage of native memory? I have to say right now the details are escaping me, but as you know, like Scala Native has been doing a lot of its own research on continuations. Ah yes, I remember now. Because of that research, I proposed a pull request, I proposed an idea which got accepted to Scala Native, which was to add this special type of data structure, which is a conservatively traced stack. Anyway, long story short is that currently the way fiber is implemented in Cat's Effect is it's like actually multiple arrays, multiple stacks. One is a stack for bytes, one is a stack for objects, and it's because on the JVM you can't really mix those two data types in a single stack. So you have to have two separate stacks that are growing in tandem. But actually it would be a lot better probably for memory access if we could just have one stack that grows, like the same way that the normal stack works, the normal call stack works. And so on Scala Native, because we made this change, we added this conservatively traced stack, we can actually now have that. We can mix bytes and ints with object pointers all in a single stack. And so I did an experiment, I think, where I changed it out or something. I was cheating a bit, and it was getting better performance. So yeah, I think we could even just sort of redo the IO fiber implementation and get some performance benefits. Yeah, there's a lot of other stuff we've been sort of playing with is different because the Scala Native has got a more relaxed memory model than JVM. Another thing we really pushed for is finding new ways to take advantage of that. Yeah, so that's a lot of what my interest is these days. Yeah. Good question.
I think I saw some other hand going up. Yep.
Thank you for the talk. You kind of shared the excitement around like SBT new type-level and type-level template, so for the new projects. I have to maintain a bunch of legacy stuff. Is it bringing something to that table? Can I use that table to update my old legacy project configuration?
Yeah, so say it again, you're maintaining a what legacy project?
Yeah, I have a bunch of old SBT projects.
Yeah, I mean, I think so. Like I shared that quote from Fabio, and like the reason Fabio had to migrate his projects finally was because Sonatype went through a whole change where the publishing mechanism changed, and so like suddenly a bunch of people have been sort of neglecting their project. So yeah, those were projects on old stuff, and he was able to migrate it and build. Yeah, I think one of the things that was when we design Sbt-typelevel, it's actually very modular. So even though there's like one super plugin that like brings in all the great things I told you, like the versioning and the compatibility and the site building, it's actually divided up into a bunch of like smaller plugins that each do something really well, but then they work really well when you put them all together. But like it might be possible that there's specific sub-plugins that are useful to you. Like maybe you just need publishing, and at this stage you're not worried about compatibility or something like that. So it's possible there's something in there that would actually be helpful to you. Yeah. We can talk more.
Okay, any other questions? If not, then let's thank Arman again.
Thanks for being here.